Anything specific from homework problems? Or general? Anything math related? I won't help you with your history. You guys, how are we doing? Where are we at with the homework? We catching up? 3-4. Hopefully you guys are getting into it. If not, gotten through most of it. Yeah. 3-3. Number 72. Oh, thank you. All right, guys, this is page 185. Page 185. So this is kind of nice. What's kind of missing from this statement that we're getting used to?
A number.
Yeah, there's nothing we don't know here, right? Don't hope that's going to happen a lot. It's not. This is one example. They just want you to go from English to math-ish. It's not even algebra-ish. It's just straight up numbers. It's kind of nice. The one piece of this that messes people up, subtracted from. It's not as evil as less than. 7 less than a number. That's low. This is specifically saying you have to subtract from this. So how do I write that? Yeah. From this, I must subtract 17. Careful. Well, they told me what it is. Equals. And in fact, they use the word equals. That's crazy. Equals negative 29. And that's all you got to do. Obviously, there's no work to do here, right? There's no x to solve for. It's just a statement of fact. I just want to translate this statement from English to math. How we doing? So they kind of wanted to focus on this phrase, subtracted from, just to make sure you turn it. It's easy to tell you do something wrong. If you do it the wrong way, and you do 17 minus negative 12, well, what's 17 minus negative 12? What's the minus and negative? Plus 17 plus 12 is 29, not negative 29. So that's really hammering home the idea of subtracted from. You got to be careful. You got to understand it's nowhere near as evil as less than. Subtracted from is telling you that's got to go here. Subtract that from this. Cool. Is that cool? Is that okay? Yeah.
I have one that's 3.3 that's 18. I just had a question because I don't know if I did it right with having.
Oh yeah, that's that one that messes us up all the time.
Oh, did you already go over this?
No. It's that kind of problem. So, in general, the people that do really well in math, there are some lucky people that just happen to look at math the right way that's going to get them through. If you can look at it as categories. I look at that problem and I categorize it as a certain type of problem. As a teacher, I have a different perspective too. I know that kind of problem gives students problems. This is where the numbers cancel. We saw a couple of that like that yesterday, or the other day. So what's obviously the first thing I want to do? Parentheses. 6, good. Okay, you can minus the 6. Get the numbers together, and of course, while we try to do that, they both die. Right? Yes, sir.
You take away 5z with 3z.
Okay, good. Is that right?
We can't say 3z minus 5z, just.
I like it. So you guys agree. That should be my next step. It doesn't matter which way you go, right? So we can certainly subtract 5z. The main thing to realize right here, and this is the point I tried to make the other day, Let me make this a little bit bigger. If I put a +1 there now, real quick, everybody understand? I'm the teacher. I can do whatever I want to. That's not part of this problem. I'm just making a point. If I put a +1 there, we have no real problem. We know to move those over. But the minute that's not there, we go, holy shit, what do I do? And I don't blame you. It's weird. But you still, are the z's together? No. That's your whole overriding motivation for whatever the hell you're doing. Get my letters on one side, numbers on the other. Nothing else matters. There's no number. I don't care. My z's aren't together. I got to get them together. Yes, sir.
What is your first step when you subtract either the 3z or the 5z?
You could, certainly.
On one side?
Yeah, you don't have to do the 6 first. You could do the z's first. Yeah, that's fine. To tell you honestly, that makes it a little less freaky. But I just want to show you this in case you do choose this route.
Wouldn't you get two possible answers, like 2 or negative 2?
Say again, sir?
Don't you get two possible answers though, 2 or negative 2?
No, you don't. You don't get anything like
Oh, yeah,
that.
right.
You get one specific answer. If I subtract 5z. Well, I know I don't divide yet because I don't have all my z's together yet. When I'm trying to move things from one side to the other, it's almost always add or subtract, right? So how do I kill these 5 z's? Subtract them. What's there now?
0.
0. And what's over here?
2.
-2.
Negative 2.
Oh, wait, so you couldn't
Now
use
this
that.
step freaks people out also. But again, that side does not tell me what to do. This side tells me what to do. What do I have here that I don't want there? -2. And it's multiplying right now, so I'm going to divide. By -2, not by 2. Right? The opposite of multiplication by something is division by that thing. You don't change the sign also. That's adding, subtracting. Here, when I divide by this thing,
2 equals 0.
and 0 divided by anything, 0.
So no matter what way you go, then it's a divided line, you're gonna get the right answer. So if you went that.
Oh yeah, if you went the other way, you're gonna get there also, yeah. You have to.
Otherwise.
Oh, no. Is that semi-decent? I mean, if that's the only kind of problem you have issues with, I'm actually happy.
That's not that.
This gets a little freaky.
Getting into the wording is what getting in.
The wording?
Yeah, when she put it in words.
Oh yeah, I got you. I got you. Yeah.
3.324.
So that's the same section of our 24. All right.
T. That's a T.
Yeah, it's trying to be a T. Somewhere back in time, I used to do T's like that. But somewhere you learn to do a T like that, so you can tell it from a plus sign, right?
I do mine in person.
Now I'll tell you this too. There's nothing wrong with this.
It's alright.
That's all right. Like I always say, I think math needs musical intermissions. It's okay. And that was well timed. There's nothing really, let me be careful how I say this. If you don't like the letter T, what does T represent? A number. Why did they choose the letter T? Maybe it's time, so they chose the letter T. You can make that an X if you want to. Now you got to be careful. In general, if you do change the letter, you better change it back at the end. In case it does mean time, you want people to go, oh, T, that's time. But if you don't like the letter T, if you don't make your T's like that, and it's freaking you out. Or Z, a lot of you guys are thinking, I do that so automatic, I got
Yeah, like
to.
two.
A lot of you guys are treating this like a 2,
Yeah.
right?
You
I understand.
can't say T. That's the
But
best.
make it a different letter. Make it Y. My Y's look like 4s. That doesn't help me out. Make it an X. There you go. You guys know my Y's look like 4s if you think about it.
Well, T.
Good. So Brooke says, enough talking, dude.
Plus 16.
I like it. So the first thing we always do. Really?
It's
Bruce says, stop talking. Do the problem. So yeah, you distribute that 4 through 12T.
12. Plus 16. Oh, shit.
I didn't. Is something. You all right?
We need a microphone.
Microphone?
Good.
You're right? You're right.
I don't know.
I'm like, I don't think anything up here warranted a holy shit yet. So I'm not sure what's going on. How are we doing so far?
You just sent me
Yeah.
clicks.
Oh, sweet.
Oh,
So Sarah, you asked this question, right?
yeah.
What's the next? No, oh, wait, stop. So Sarah, what should I do next?
16 and
I like it, all right? Sorry, Fruit. I just want to hear her say that. So what's 16 minus 20? Yeah, minus 4.
I was like, hang on, give me a second.
All right. So you always distribute first. If there's anything to distribute, then you get your like terms together if there are any on each side. And then when you hit this step here, we got t's and numbers on both sides, you just choose a way to go. Right? So what do you want to do now? Okay, beautiful. So minus 5t. Get my t's together, kill them over there so that they effectively show up
18,
on the other side.
17,
7t.
minus 12.
And everything else is still exactly where it was. Beautiful. Add 4.
17.
Yes, sir.
T equals 1.
Beautiful. Because the last step is almost always divide. I like it. Real quick, anything about that? Is that? Yes, ma'am.
So anytime you move, like, if there was 3 on that side, if it was minus 3 on that side, you would like plus 3 on the other side?
Exactly.
So anytime you just switch it?
Basically, yes.
Okay.
You got to be really careful about making it too simple, but that works. You just got to make sure that it actually is subtraction or addition. I'm still seeing a lot of this. Can somebody tell me what's wrong with this? This is error. Be careful. Somebody's going to write it down and say, well, you said to do it like this. Yeah, what? What's the mistake that was made here?
The 4 is being added.
Yeah, this is not, they thought this was subtraction. They focused too much on it being a negative 4. But the operation is multiplication. So to undo that, I have to divide. So a lot of you guys see this note on your homework. Addition won't cancel multiplication, blah, blah, blah. Right, but your brain, it's really easy to just see that negative 4 and go, plus 4, yeah, that'll work. You got to really slow yourself down and go, that's multiplication. So the right way to do this, of course, is divide by negative 4. I like that. Okay. Real quick, one last thing. A lot of the homework I'm grading, the people that are making the most mistakes are the ones that aren't showing themselves everything. You know who you are. Right? And that this is more than just me giving you arbitrary rules. This is what's going to save your ass from making mistakes. Do something, rewrite everything. Do something, rewrite everything. Do something, rewrite everything. Blah, blah, blah. That is the way to really work through these things. The more comfortable you get with this, the quicker you can make that process. Sure. Not yet. All right, so, yes, ma'am.
3.369.
Okay. So here's how I personally would do this. I see 3 times something, right? 3 times what? The difference. So it's 3 times the difference of what and what? Of negative 14 and 2. So how do I write the difference of negative 14 and 2? You guys with me? So it's the difference of negative 14 and 2, 3 times that. So I have to have that outside the parentheses. These have to be together. The whole thing is multiplied by 3, not one piece or the other piece. Amounts to, equals, negative 48. Cool. And now you stop there, really, but you can check yourself. Does it work? Negative 14 minus 2 is
16.
negative 16. Times 3.
Negative 16.
Yeah, negative 16 times 3.
48.
Incredibly enough, it's negative 48, thank God. Will I ever be fully healthy? Yeah.
When you have the quotient of negative 16 and 2, is that negative 16? Do you write it negative 16
Yeah.
divided by 2?
Everything else is in the order it's given,
Okay.
besides that one less than, right? So if I say the quotient of 8 and a number, it's 8 over a number. It's the order that they gave it to me. Cool. Okay. All right. So, let's get back into chapter 4. So last time I gave you guys several problems just to see where we all were. So now I'm going to pull it back and slow down through some of these things, some of these more specific things. And I like to talk about, in general, I like to talk about pizza. And I'm sure you guys have seen the examples with all kinds of just cutting things in parts. But that's the whole idea of fractions. It's cutting something in parts. This, right now, I got my pepperoni and I got my whatever the hell else, and that could be a cookie, I don't know. So right now, that's one whole thing, one whole pizza. So really, the whole idea of fractions is realizing that there have to be numbers less than 1, realizing that there have to be parts of something. Right? Parts of 1, hello. So if I were to slice this into 4 pieces, then another way to say how much pizza there is right there is that there are 4 slices out of 4. There, right? None of them are gone yet. So I cut it into 4 pieces and I have all 4 of those pieces still. Cool. So the minute somebody comes along and grabs a slice, so this slice is now gone. Right? It's the whole pie. Now 1 slice gone. How much of the pizza is there now?
3, 4.
Yeah, 3 slices out of 4 that I had originally. All right. So that's the basic idea of fractions. That's all really that fractions are trying to get at, is that you can't always go 1, 2, 3. You sometimes go by steps of a half or a fourth or whatever, right? 1 slice gone, so now I got 3 out of 4 pieces. Okay. So another thing I like to think of is, let's see, if I had a thing of, let's say, I can't remember if I put this up here last time, eggs, egg carton, right? Oh, I said ice cubes last time? So now we'll make it eggs. And let's say that this whole tray is full of eggs. And there's an egg for you. That, of course, would be what fractional piece? That's one whole carton. What fractional piece is it? How many compartments are there? 8. So out of 8, I currently have 8 eggs in there. All right, so far so good, right? Nothing major there. Now imagine this. Let me take us a step back. Let's say I've got this same card and I'm just starting to fill it up. So I've only got that there. So of course, what would that be? 1/8. So it's 1/8 of the way full. So if I put, some of you guys are like, hey, watch it. If I put another one in there, of course, that would be 2/8. But another way to look at it, of course, is I got 1, 2, 3, 4 groups of 2. And how many groups of 2 do I have filled up? 1. So of course that relates to 2/8 reducing to 1/4. Okay, cool. There's a point to this whole thing. So if I get to the point where I fill this thing up again, I got it all filled up, and I got 3 extra eggs sitting over there. Right? So I'm filling up egg cartons. You can imagine there's a bunch of egg cartons next to me, and I'm just the poor fool that's been hired to fill them up. Okay, that's crazy. This is, of course, 8/8 or 1 whole carton. How much of a carton is this? 3/8. I'm not quite there yet, right? I can't fill another carton up yet. So this is like an extra 3/8. So that's 1 3/8 cartons. What's a whole other way to look at how many total individual eggs do I have? How many total individual eggs do I have? 11. Out of how many spots? 8. So that's why this, of course, is what you call, what do you call this thing?
Improper fraction.
Improper. And I always think of it more like an unbalanced fraction, right? Not like it's going to become homicidal, but it's kind of got, what it's saying is I can overfill a carton. I've got extras out there. Kind of with me? All right, so this shouldn't be anything ground shaking, but I want to make sure we all start off on the same foot with fractions. Now, normally you guys understand the basics of fractions decently well. It's when you have to start working with them that life gets rough. Yeah. And let me do something that's going to seem entirely unrelated, besides just time issue. How's this related to fractions? I don't know. What is x plus x?
2x.
All right, I like it. What is x plus y? Be careful now. See how evil I am? That's not really a trick question.
X plus.
And real quick, I want to point this out. If you said x, y, what operation is that now?
Multiplication.
And it used to be addition. That can't happen, right? The main idea here, of course, is that these two are not like terms. Because here's the really cool thing about fractions. Stay with me, everybody. This is nothing ground shaking here either. Let me see if you guys can do this next step. If I do have x plus y, I can't do a damn thing with them because they're not like terms. If I told you something about y, so if I said, oh yeah, y is twice x, whatever the hell x is, y is double that. So now we know more about it. You with me? I can't do shit with x plus y. I don't know what either one is. I don't know how they relate. They're not like terms. You can't do shit. But x plus y, if I tell you, oh yeah, y is twice x. Let me see if somebody can do this for me. What can you do now with this information?
Just change the y to 2x.
X plus 2.
Yeah, this will be x plus 2x. And now what's that? 3x. All right. Now you're all like, what the hell does this have to do with fractions? I'll show you.
I like the program.
So what is let's see. What is what, Jeff? I don't know. What's 1/8 plus 1/8? 2/8. Which we happen to be able to, if we want to, reduce it to 1/4. Because you can divide the top and bottom by 2. Cool. Now, what is 1/8 plus 1/4? Now, I want you to realize, that first question was like this. Something plus its...
1/12.
Guys, stay with me. Hold on. Don't make me shout over you. Hold on. My first question up here was, what is something plus itself? So they are obviously like terms. Stay with me. This now is like this. I cannot, do not tell me 2/12. Please, dear God, do not tell me 2/12.
You have to times that.
Somebody out there is like, that's what I thought it was.
You have to times that 4 times 2.
The main issue with this, the reason, this is the way I like to teach fractions is, to add them or subtract them, they actually have to be like terms. You cannot add or subtract anything that's not like terms. So what do I have? I have 1/8 plus 1/4. I can't put those together. It's like 1x plus 1y.
So you got to find
But
the
I
common
do know,
denominator.
information about this, don't I? I do know that 1/4 can be written as 2/8. Right? If I multiply top and bottom by 2, So this whole process of getting like denominators, I wanted to make sense why that's gonna happen. Because people seem to forget why that must happen. It is purely because of like terms. I can't put 1/8 together with 1/4, the same way I cannot put 1x together with 1y. I can put 1/8 plus 2/8 is 3/8. Cool. Not 3/16. I don't have any 16ths. How do you have 3 of them now? I have 1/8 plus 2/8 is 3/8. That's why the bottom doesn't change, because it's just like x and x. They don't change. You're just counting how many of them you have. How are we doing so far? Okay. I have no idea where in the book I am. I'm just gonna kind of jump around a little bit. Okay.
You still working with the pie.
Not really. I kind of left the pie way behind. I'm hoping we won't have too many troubles with that. We'll see. So here, you guys try this. Okay. No, it's way up there. Could be. Why do you say that? And some of you guys are used to doing like this, and that's perfectly fine. This stays 2 nights. I can make the 3 become 9, so I can make them like terms.
So that's 3 times 3, and then 3 times 1.
Good, so 3 nights. And of course you get
5.
5 nights.
5.
So if I had 2 nights of my gas tank full and I put in 1/3 of a gallon of gas, 1/3 of a tank, I'd still have 5 nights of my gas tank full. Right? Okay. Can you tell me, this is like a little side note. I'm not sure if anyone want to ask. Is my gas tank more than half full or less than half full? Why?
Because it's on the 9.
Half would be divided
Because
by 9. If you divide 9 by 2, that'll give you the half. It's be 4.5, yeah, 5 times 5.
Oh, I got you. You're thinking a different way than I was. I like that. So not half of 9 would be 4.5. So 4.5 should be up top if it's half. So it's a little over. And the way I think about it is 5/10 is a half. So 5 divided by a smaller number is bigger. So I actually have more than half. So I love it.
Or you,
Watch this.
or you know, 9 ninths is 1.
You guys, stay
or
with me.
10.
Stay with me. 5/10 is 1/2. What happens if I take a number and divide? So if I divide 5 by 10, I get 1/2. What if I could divide 5 by something less than 10? If I divide by a smaller number, my answer will be bigger. Therefore, 5 ninths must be bigger than a half. I must have more than half a tank of gas.
Yeah.
That's important to realize. That's kind of like a little bit further along here, but that's how you can compare fractions if you can't quite do what you did. Doesn't always work that nice, right? But still, it's. I love the way you guys thought about it. Not the way I thought about it myself. And neither one of our ways is better. Doesn't mean a damn thing about it. Just because I'm the math guy doesn't mean I have a better way to think about things. Right? Just, I have my own way to think about things.
Trying to make it come to a good solution.
All right. So what about? Try a couple more here real quick. course, number 2 is just that extra little step harder, right? There's no way to make 4 become 6 really easily. I don't want to do that. Can't be, I can make 5 become 15. That one's not too bad.
Do we have to use the same number on both sides, or can we do different?
You have to use the same number top and bottom.
Yeah.
But thank God you can use different numbers on each.
Okay.
Otherwise, they would never match up. Right? So this guy here, of course, this guy stays the same. What do you do with him? Times 3. 4 minus 6. Negative 2 of these. Cool. Right? Don't say negative 2 over 0. Don't subtract the 15s. That's bad. It's undefined freakiness. So what about this guy? You have to do both of them, right? Now, guys, the main idea with these like terms, which are more commonly called like denominators here, right? LCD, lowest common denominator, that kind of thing. But I like to make you realize that it's just like terms. It's exactly what it is. To make these agree, you have to do something to both of them. So where can they meet? What number can they both multiply up to be and meet? 12. Now if you thought 24, I understand. You multiply n by 6, n by 4, but there's a smaller number than that. Yeah, the lowest, the LCD, the lowest common denominator.
We can't do 24. We can't do it.
Sure, you can do 24.
It's too much.
Of course. You gotta be careful. If I ask for LCD though,
No.
it's gotta be the lowest. Cool. So if you did do 24, it would reduce to the right answer. So let's see, what do we get here? So what do you have to multiply this guy by to make 12 on the bottom? Times 2. So now you got 14 over 12. And this one you got to multiply by
3.
3 to make it 12 on the bottom, right? So now I have 14 twelfths minus 9 twelfths is 5 twelfths. How are we doing? Are we semi-decent? So if you made it 24, you got 10 24ths. That would reduce to 5 twelfths. Yep.
It's been a really long time since I've done this. Lowest common denominator is the
Let me show you a
number that
trick.
multiplies, right?
The number that they can both multiply up to be. Yep. So let me show you a really cool trick that will work, especially when these get really ugly on the bottom. What you can do for this problem really is watch. You start writing multiples of 6 and start writing multiples of 4, and then you see where they match. The first place they match is the LCD. Now you can imagine I can make these other really kind of ugly numbers, and it takes a while for them to match, and like, oh no. So this is not always a good way to go. Let me show you a nice trick. Guys, my little group, please. Here's a cool thing here. Oh, what's it? I don't know. Yeah, that'd be right. Now watch, this is kind of nice. I want you guys to get this right now. Because I show this thing to my pre-calculus students and they've never seen it before. I'm like, come on now. This is a really nice way to do this. What number do they both have in common already? What factor? What number goes into both?
5.
5. 5 goes into 35 how many times?
7.
7. 5 goes into 30 how many times? 6. All right, let me see if I can keep you guys with me. So that's step number 1. You do not have to do this. This is a suggestion. This is an option. You with me? This is not something you have to do if you don't like it. Now watch, this is kind of cool. Don't the bottoms both already have 5? That's where we started. What is he missing that he has? What does he need that he's got? A 6. You guys would see that? Doesn't he have a 6 that he doesn't have? So I'm going to multiply top and bottom by 6. Stay with me. What?
We're lost.
Oh, okay.
Left field.
Yeah, like how did
Alright.
you know that 6 just came out of like nowhere?
No, I didn't. It's right there.
Right. No,
Yeah, but-
So what is he missing that he's got?
Six.
Now let me back up a second. Let me show you how that's exactly what you guys did earlier. If you do 1/9 plus 1/3,
Right.
So you get 3. It will come with the 9, right?
guys in the back. Now, what do you do here to add these?
You multiply
3.
Multiply by what?
by
3.
By 3. Why did you multiply by 3? Because he's got 2 3s and he's only got 1. So you gave him what he was missing.
Right.
Why is he not the same as him? Because of his extra 3. Okay, I'm going to multiply him by the 3 because that's what he's missing.
Okay.
Why are
What
these
about-
not the same?
Because he missing a 6.
He's missing a 6
But
and he's missing a
it's not
7.
Got it.
Now, if you multiply this guy by 6 and this guy by 7,
Yep.
aren't the bottoms the same now?
Yes.
Yes.
That'll work. Leave that.
What is that number? It's ugly. You can work it out. You guys semi with me. Now, if you don't like this method, never do it. I don't care. Personally, this method kicks ass. Especially when the bottoms get really ugly. You think, what do they have in common? And then you break it down, and then you can just see who's missing what. Let me give it to you. That's the whole idea of LCD. Give everything what they're missing, so at the end, they're the same.
So it's got to be to come out to the same.
Yeah, so what do I get on the top here?
6.4.
24. Careful now, don't worry. And what do I get on the, what number is this? 30 times 7? 210. And what do I get up here? All right, so we get a 49 up there, right? And on the bottom, of course, is still 210. All right, cool. And then you just put those together.
Oh, so you're not even doing like this the second row.
Say again, sorry?
Like you're not doing the 6 times 35. 'Cause you-
Yeah, I did. Yeah, what's 6 times 35? 210.
Oh.
Yeah.
So what do you do with
Is
the
that
last one? The
hard?
last one you don't.
This and this are the same. This is just rewritten. Is that
Oh,
cool?
yeah, yeah, yeah.
Okay, good. All right. This is just me working with the bottom. So they're both the bottom. Okay, good. You could have done the same thing here. 6 is 3 times 2. 4 is 2 times 2. Multiply him by the missing 2, him by the missing 3, and that's exactly what we did. Right. Now, in that problem, it's a little, you don't have to go there, because you can see it's 12. It's not that big of a deal. That problem, I can't just look at 35 and there and go, oh yeah, it's 210. Yeah, but I don't know shit. So that got me there. So what do you get at the end here?
73.
Cool. So it sounds like a couple of you guys kind of follow me. If you don't like that, it does require that you are a little comfortable working with the numbers and figuring out what number goes into both and all that kind of stuff. If you have another way you do this kind of thing you like better, great, do that. All right. Let me ask you, in order for this next thing to make a little more sense, let me see if you guys are with me on this. And we've done exponents before. We talked a little bit about powers, remember? So somebody help me out. Can I do this? Can I add those together?
No.
Why not?
No.
Not like terms, I love it. Can I multiply them together?
Yes.
Yes! What do I get when I multiply them together?
X to the third.
Beautiful. When you multiply these, what do you do with the powers?
Add it.
Add them. Cool. Okay. So what does this have to do with anything? When I add or subtract fractions, I must have like terms. when I multiply or divide fractions, I do not need like terms. Right? Did I just multiply two things that weren't like? I can't add them, but I can multiply them. What's up? Are you okay? So here's an example. 2/3 times 5/7. Careful now. So let me dispel this myth immediately. The one time that you cross multiply is if I have something like x over 7 equals 6 over 9. That's when I cross multiply. It's actually a shortcut of solving that equation. You only cross multiply when you have the equation with some fractions in it, and you cross multiply. That's the only time. The only time. You with me?
So can you do this straight across?
Exactly, you have to. Right? And actually, well, let's do this one, and then I want to back up one more step just to show you really why this is. So what do you get on the top there? 10? 21. Let me. So if I had, let's go back with our variables real quick. If I had 1x and I multiplied it by 5, what do I have now? If I had an x and I multiplied it by 5, that is 5x. I love it. So if I have 1/8, like I had 1x, I have 1/8, and I multiply it by 5, I should have 5/8. And what's underneath the 5? 1. Always understood 1 under a whole number, right? So if I multiply straight across, I do get 5/8. Okay. Okay. Maybe. So let me ask you this. If I had 6 apples and somebody took half of them, I would now have 3, right? So if I have 6/7 and somebody came and cut that in half, somehow I should end up with 3/7. You with me? 6 somethings, if I cut them in half, I should now have 3 of those things. Well, let's work this out 2 different ways. 1 times 6, 6, 2 times 7. And what does that reduce to? 3/7. Cool, right? 1/2 of 6/7 should be 3/7. You with me?
Yeah.
Okay. The other way to do this problem, the slightly better way to do this problem, because it will help you when these get more disgusting, is to first reduce before you multiply.
2 times 1 and 6.
Exactly. Because anything that's on the top is multiplying, anything that's on the bottom is doing what? Dividing. So isn't the 6 up top and the 2's down below? So 2 goes into 6 how many times?
1.
Right? And of course 2 goes into 2 once. You guys semi with me? 1 times 3 is 3. 1 times 7 is 7. So really the only thing we're doing is either you reduce at the end or you reduce at the beginning. Let me show you an example of why I don't want to. Oh, great. Is this truly, the one thing you have to be careful about is you can't reduce anything like a cross. That doesn't make any sense. If they're across from each other, they want to multiply. If they're one's up and one's down, they want to divide, don't they? That's the whole point here. So what if I had this? What, Jeff? I don't know. That's looking good, nice and ugly. Now, can you imagine? I want you to think about this for a second. If you did just multiply this through, would you not get tremendously, disgustingly huge numbers? And the larger the numbers are, the more difficult it is to reduce. So what I do is, I don't let my numbers get big. I kill them now when they're small, right? What goes into both 49 and 35? 7.
8, 5,
So there's a 5 there,
7.
7 there.
Yeah.
We doing okay so far? Anything on the bottom can reduce with anything on the top. Because this is multiplication and this is division. They should cancel then, right?
Yeah.
It's 16.
16, 1, 1, 4.
Good. So what do you get now when you multiply?
7.
7?
20.
Multiply. Yep, cool. That's a lot better than if I multiplied, I would get 784 over, I don't know, something, 320, 320, 30, 18, 20, 320, 2140 maybe? Can you imagine, that might be. Can you imagine trying to reduce that thing there? I mean, this is a lot easier here to reduce this. Now, let me follow it up with this. You do not have to reduce first. There's nothing that says you must. You can always multiply first and then reduce. I'm just trying to show you why it might be better to get used to reducing first.
It's faster.
It's quicker. They're easier numbers before they multiply. Okay, maybe. So we throw a little curveball in here, of course.
Oh, yeah.
The change up, yeah.
Change that.
See how far they go with this. This is not a major thing. I have thrown variables in there, but what's really nice, careful. Okay, the 14 over 18 becomes what? How does that reduce? Good, because you can divide both by 2. Now what happens, what's x divided by x? 1, 20. They cancel. Right? Nothing major there. Nothing major at all. Because again, let me show you an example, an easier problem. 15/20ths. What do they both have in common? 5. 15 is 5 times 3. 20 is 5 times 4. So what can you do with those 5s? Cancel them. Anything that's the same on the top and the bottom just goes away, right? We often don't show ourselves this step because we can see 5 goes into both and we just do it. So that should hopefully make more sense here. If I have an x on the top and an x on the bottom, they just go the hell away. Side note, can anybody tell me what x can't be here? Because remember, x is any number. In this case, it can't be a certain number. 0. Because it can't divide by 0. Just want to make that point right now. But don't even worry, it's not going to come up. If I see a variable on the top and the same one at the bottom, I kill them, just like I would with a number.
What if they're different?
Then you don't kill them. You leave them alone. So if I had, for example, watch out, I don't know, 12AB over, I don't know, Jeff, what? You can do it, 15 AC. I like
All this here.
What if you cancel off both of the A's, the leftover would be the B and C?
I love it, right?
Well,
And what can you do with the numbers? Let's start there.
3.
Yeah, they both divide by 3. 4 fifths.
4.
And like you just said, the A's go away. Does anybody kill that B or that C? So they're still there.
No, no.
Before Christ.
All right, PC if you want. How are we doing? Is that, do you guys see that? There's nothing major about variables. They're just numbers we don't know. If the same one of them is on the top and the bottom, I can just kill them without even knowing what the hell they are. It's the same, kill them. It's just kind of like the ultimate level of that you're going to see. Some of you guys are like, what, that's not it right there? show you. Let me do this problem out without skipping any steps. You ready? Yeah, what do these both share? 9.
9.
So 18 is 2 times 9.
3.
And 27 is
3.
3 times 9. Now x squared, write it in expanded form. X squared is x times x, 11. And a cubed is a. We with it? Okay. And on the bottom I have x and I have a. So now you just start killing. The 9's go away. Those x's go away. 2 of these a's go away. So what's left alive? What's alive on the top?
5.
Yeah. Careful now.
5XA.
There's no 5s.
2XA.
2 xa over 3. So if you need to, you can show yourself this step. Here's a slightly better way to do it. That's fully all the way out. Just break everything out. Kill. Right? Here's a slightly quicker way to think of it. 2x is up here, 1 down here. How many cancel? How many's left? 1. 3a's up there, 2 down here. How many cancel? 2. How many's left? 1 on the top. Right? You're sort of doing this, but you don't have to actually write it out for yourself. So whichever way you have to do it to make it make sense, do it that way. How are we doing so far?
I need I can't see straight, so I see it too many.
Oh, no, there's too much stuff up there. I got you. All right. So, does somebody remember what's weird about division of fractions? Everything. This is good. Yes, ma'am.
Do you use the same change flip motto?
Do it one more time.
Do you use that same change flip motto in division?
Oh my God. What word is that? Change?
Change flip motto.
Just go ahead and do it, and
I'm sorry.
I'll answer my own question.
All right. But what was it you're saying?
Same change flip.
Same change flip.
Yeah.
If that's when you multiply.
Oh, I see what you mean.
Or when you divide them.
Sure. Okay. So that's just kind of like a saying to remember?
Yeah, through division, yeah.
Gotcha. But I want to even go further. I want to explain why you do it. It's one thing to remember that you multiply by the reciprocal. Some of you guys might remember that, some might know it. It's another thing to know, why the hell do we do that? Right? So let me show you an example of why when dividing fractions. And then I'll show you just a regular problem. So this is not the way I would do this problem. You with me? I'm just showing you why we do it the way we will. 7 divided by 1/3.
Take from 7 and make
This is kind of new, by the way. I came up with this method. We'll see what you guys think of it. Because I don't know if you've ever been explained, why do you multiply by the reciprocal? Why does that make sense? And I've actually got a couple ways to explain it. We'll see. Can't I, now just go with me, trust me. You never have to do this. You don't have to write this down if you don't want to, just watch. Couldn't I rewrite this as 7 divided by 1/3 if I really felt crazy?
Yes.
Yep.
All right. What sucks about the denominator? What sucks about the denominator?
It's not whole number.
Currently, I'm with you. You're one step ahead of me, so let me catch up to you. There's the denominator, right? That obviously sucks. It's a fraction inside of a fraction, right? But can't I multiply top and bottom by something to kill this fraction? What would I multiply by to kill this fraction? By 3.
By 3.
If I multiply top and bottom by 3, doesn't that go away? Don't I now have what on the bottom? What do I have on the bottom? A 1. On the top, I have 21. So effectively, what did we do? Division by 1/3 became multiplication by 3. Multiplication by the reciprocal. Right? How we doing? Don't worry. Yeah, exactly. That's the method to do, by the way. That's just the way you got to do it. So this is just me trying to explain why it works. Let me try a more physical reason. If you knew that a box was full, You know, box was full of apples. For some reason, we always talk about freaking apples. But you can only see half of it. Stay with me now. If you knew that a box was full, but you can only see half of it, and you see 2 apples sitting there, how many apples, of course, are in the whole thing? 4. So you have 2 apples in 1/2 of a box. 2 divided by 1/2, you know physically that's got to be 4. The only way that can happen is if you multiply by the reciprocal, 2 times 2. So 2 divided by 1/2, and if I divide by a small number, my answer should be bigger. So sure enough, 2 divided by 1/2 has to be 2 times 2/1. That's 4. Physically, we know there's 4 apples in there. The math better come along and say the same thing, or we're going to say, screw you, math, get that lie. Some of you guys say that anyway, even though it's right. I don't know if you guys like either one of those. But let's just focus now on a concrete problem. Here's all you have to do. You can go home anytime you want to. This is college. So if I add something like 6/7 divided by 12 over 21. Let's make it 35. Just because.
What?
You guys with me? No. Are you with what I've written so far? Yes. Okay.
Do we have a choice?
You always have a choice. All right. So the process. There's 2 reasons why this process works. But here is what the process is. This is all you got to show me. You don't have to draw little boxes with apples. You don't have to do that thing. So this is what you're saying. Same. So this first guy stays the same. You flip the bottom. You flip the second guy. And you see why. You have to flip the second guy because he would be on the bottom. He's the freaky part. This is the freaky part. So you multiply by the reciprocal. Same, change, flip. That's what you got. Right? I've never said it like that, but yeah, you multiply by the reciprocal. You guys have heard that word before, reciprocal? I keep saying this.
It's
That just means
easier
to
way
flip.
remember it.
Reciprocate means to flip the fraction around. In English, reciprocate means if
Do the
you,
same
if you
as-
love me, I love you. I reciprocate. You know. But in math, it means it's sort of the same thing. Turn it back, turn it around, right? Cool. Okay. And now you attack that like you would any multiplication problem. What's a good first step? You don't have to do this. It's a good first step. 6 goes into 12 twice, and 7 goes into 35 5 times. 1 times 5, 1 times 2.
So if you cut 2/5, that would be wrong?
Yes, it would be wrong. You can never flip the first dude. You always multiply by the reciprocal of the second dude. Always.
Why are you
Just to make it
That's what I was
logical.
trying to explain here. It can't be left alone. It can't be the same answer I would get if it was multiplication. Right?
That's to make it come out even.
And here's another way to look at this. If I divide something by 2, is there another way to say that? If I took your money and divided that by 2, is there another? I've done what your money? I've cut it
X over 2.
in half, right? So division by 2, if I have 8 divided by 2, should be the same thing as multiplication by a half, because dividing in half is cutting it in half. You guys kind of with me? So sure enough, if I do 8 times the reciprocal, 2 goes into 8. There you go. It is 4, the way it's supposed to be.